Welcome back to my channel, Spark Virtual Academy. And in today's lecture, we are going to learn about one of the physics topic, projectile motion. We have been studying about the motion since our 8th class or since our 7th class. We have studied only about the three types of the motion, the linear motion or the translatory, which is known as the circular or the rotatory motion, and then we have studied the vibratory or the oscillatory motion. All the three motions that we have studied already about the motion, those are all on the same plane, on the x-axis, on the horizontal plane, we can say, like on this axis only, horizontal axis. Or we have studied some of the motions which are also in the vertical direction. For example, those motions are in this direction as well. So up to now we have studied only the motions in two directions separately, either the motion in x-axis or in the y-axis. And today, the motion that we are going to learn is the projectile motion, and it is the motion which takes place in the both planes simultaneously. It means projectile motion is that type of the motion which is under the influence of both the x-axis as well as the y-axis. Or in other words, we can also say that the motion of a body, which is under the influence of gravity, and that motion is known as the projectile motion. So let's suppose we are considering a vector here. Let's suppose this is the origin, and we have a small ball here, and we have just kicked it. Now, if we kick this ball from here, it will go in this direction and it will fall here. So you can see there, when we kick this ball from this origin, it has covered the both distances. Up to there it was moving up, and from this point it started to return back, and finally it strike back to the ground. So such type of the motion is known as the projectile motion. It means if we are kicking a ball from the ground and it is following a curved path there, so it is the projectile motion. Or the other example of the projectile motion is what? Let's suppose this is x and y axis, and we have a ball here, and I'm throwing this ball. I am throwing this ball with the initial velocity of v naught, and how it will fall down, it will move like this again, and then here it will strike the ground, and that was the origin. So again you can see there, I threw the ball like this, or I kicked a ball. In both of the examples, the path which was followed is curved. Now the motion, that is projectile motion, it always follows the curved path, or the parabolic curve is there, you can see there. So we are moving towards this example in which we kicked a ball from the ground. When we kicked the ball from the ground, let's suppose the initial velocity was v naught. We are just making it darker. We are making the path darker here. It followed that much the path. So that is the origin, and this is the horizontal path that body covered. That is the horizontal path that body covered. We can say that that is the horizontal range. Means the point from where we kicked the ball and it reached the maximum distance here on the x-axis. Now the distance is known as the range. This is the point where body stopped moving up and it started to move down. Now that point is known as the maximum height. H maximum we can write down here. The maximum height is there. It means the ball reached the maximum height and then it started to follow down to the x-axis there. When the ball is here, it is following some of the velocities. For example, the upward velocity is there. If we resolve this vector, and the other velocity is in the x-axis here. If we say that here the ball has two velocities, one is in its x-axis and we can say that it is v0 x, and the upward, that is the v0 y. But we should note down one thing, the body which is in the projectile motion, when it is moving from this point and it is moving upward, it is against the gravity. So till this point, the value of the gravity will be negative. And after that point, when it is coming down, the value of the gravity will become positive. However, at the initial stage, we just resolve this vector. The initial vector means the velocity with which the ball was kicked initially. We have just resolved it into its x-axis and into its y-axis, and we already know that what are the factors, or what are the x component and y component. So we can write down here like this: the x component will be v naught cos theta, and y component is always given as v naught sin theta. And if we want to find out the magnitude of this initial vector, we can say like this: it can be given by this formula, that is vx square plus v naught y square. Okay, it is the initial velocity when we kick the ball, and that was the v naught. When the ball is traveling in this direction and when it reach its maximum distance, the horizontal range, at this point, the velocity will be final. If we take this point, at this point the values of x and y are 0 and 0, means the ball is at rest, and the maximum the horizontal as well as the vertical distance, they both are 0, because this is the origin point. As the ball is moving, and when it reaches this final point, the values of x and y becomes r and 0 again. At this point, the vertical distance is 0, however the horizontal distance, and that is equal to r. R means the range, or we can say that r is equals to the x. So we can also find out the x from the basic equation of velocity, and it can be equal to the v naught xt. We have written here the horizontal velocity v naught x because at that point there was no any vertical velocity included. So that's why we just consider the horizontal range is equals to the velocity of the body in the x-axis, and then it is multiplied with the time again. And it is derived from the basic equation, the equation of motion, that was s is equals to v naught into t. It is derived from this formula. And if we want to find out the final velocity at that point when the body reached this point, so we can write it down from this formula, that is the first equation of motion. We can replace this vf with vy, and initial velocity will be v naught x certainly, and then a will be g, and then t. So we can write down for this this final velocity like this, in this manner. So these are some of the basic terminologies related to the projectile motion. And apart from that, we should note down the body which is moving in the projectile motion, it should follow the curved path. It should have the acceleration that is due to the gravity only, and the motion of this object, it should be free of the resistance like the air resistance, or the rotation of the earth should not affect this body. Then we can calculate the equations for the projectile motion. However, we should note down these are some of the basic terminology of the projectile motion. And apart from it, the things that we have to drive related to this projectile motion are very simple. We have to determine the times, the time to reach maximum height. It means when we kick the ball from the origin, and at what time it reach here at the maximum height, we have to calculate this time. And then we have also to calculate the time of flight, means the time for which the ball remain in air from this point to that final point, and that is known as the time of flight. And after the time of flight, we have to determine the formula for the horizontal range as well. Means and what equation and what values we can find out this horizontal range. So we will calculate that formula as well. And then nevertheless, and the last, that is the maximum height, the formula for the maximum height. So these are the 4 things that we have to drive today in this lecture. So stay connected with my lecture till the end, and we will learn to drive these equations for the projectile motion. Okay, so let's move towards the first derivation, and that is the derivation for the time to reach the maximum height. So let's come back towards this picture again. As you can see there, when we kick the ball at the initial stage, the ball was at rest. So the initial velocity will be considered as 0 here. And when it reached this point, certainly the final velocity will be equal to the Vy. It means for the derivation of the time to reach the maximum height, we have to consider this picture again, and we have to consider the conditions as well. Initially, the ball was at rest, so the initial velocity is 0. And when the ball reached this point, the maximum height, the final velocity was equal to the Vy, because here the only motion was the vertical motion. So we are going to use the first equation of motion to drive the equation for the time to reach the maximum height. And we know that the first equation of motion is Vf is equals to Vi plus At. So here the final velocity will be equal to V naught Y, and that is equals to, and Vi is 0, and this A will be equal to G. The G, because the motion is under the influence of gravity here. So that's why we just consider it as G, and the time is there. Or we can write down when G comes towards this side, it would be V naught Y upon G. Since we know that the vertical component V naught Y is always equal to V naught sine theta, so the time will be So that is your first equation, and that is the equation for the time to reach the maximum height. The things that we have to keep in our mind is the consideration of this picture, and what should be the initial velocity that I told you, that will be 0, and what should be the final velocity, that will be Vy certainly. And then we have to use the first equation of motion, and then we just put the values and we get the answer. Now at this point, the velocity of the time of the object will be V naught sine theta upon G. When the same ball will come down at this point, so it will be the total time of flight, and certainly the time which is taken to reach the maximum height, and the same time will be consumed to return back to the ground. So the next topic is the formula to find out the time of flight. Very simple. We will just twice the timing. Okay. So I'm just writing down here the time of flight will be, we can denote it by t, and it will be equal to twice the value of t. So we can write down the formula for it like this: 2 and then the same value v naught sine theta and divided by g. So that is your equation number 2. Now we will move towards the third derivation, and the third derivation was to determine the equation, the formula for this range. So let's move towards the range. Okay, so now we are going to determine the formula for the horizontal range, and that range starts from this origin and it reaches the final range here. So we have already considered here in the picture, and I told you the initial points were 0 and 0, means the values for the initial point, this point, were x and y was equal to 0 and 0, and then we have to determine the range from this point to the final point, and at the final point the points were r comma 0, or we can say that x comma 0. Basically this horizontal range, it is denoted by x, the capital X there. And here the value of the y is 0, because at this point, again you can see there, at this point the value of the y is 0, means it is the horizontal x-axis, and at x-axis the distance of the y is 0. Now we should keep these 2 points in our mind, and then we are using the basic equation, and the basic equation is x is equal to v naught x, and that is multiplied by time. We have taken this equation, as I told you already in this lecture, that we have taken this from this formula: s is equals to v into t, from the formula of the displacement, or from the velocity, you can see there. Now we are going to put the values in this range. We already know that what is the value of this v naught x. That is the x component, and it is always equal to v naught cos theta. Since you can see there, the body started from this origin, and the complete flight was there, and it reached there. So the time will be considered as the time of the flight. We are not going to consider the time to reach the maximum height, because the complete flight, the complete path is used. So this t means the total time of the flight. So we determine the formula for this time of flight, and it was equal to 2 v naught sine theta upon g. We are going to use these both in this equation, in the first equation. So we will just put the values like this. Instead of v naught x, we will put v naught cos theta, and that is multiplied by 2 v naught sine theta upon g. Now we are going to solve it, but here we have to just rearrange the things like this. We have to multiply this v naught with this v naught, and it will be v naught into v naught square, and then we have to carry this g outside, and then we have to put a bracket, and then we have to write down this 2, and then this cos theta, and then this sine theta together. From the rules of the mathematics, trigonometry, this is the formula of the double angle formula in trigonometry. According to that double angle formula of sine theta, sine 2 theta is always equal to 2 cos theta into sine theta. Now we are going to replace this complete bracket with this sine 2 theta. So the horizontal range will be equal to sine 2 theta. Now that is the formula for the horizontal range, the third equation that we determine. Let me just repeat the things again. We just consider this picture again. The initial points were there, the 0, 0. The body started from here and it reached the final point that was equal to r and 0. R was the horizontal range and we can take it as x. And y is considered at 0. Then we started the basic equation and that was derived from s is equals to v into t, as the horizontal distance is there, so it is equal to x, and velocity was only horizontal distance was there, so we considered v naught x, and the time of the flight was there. We already know that the horizontal component is always equal to v naught cos theta, while the time of the flight we just determine in equation number second. Then we use these both equations in this first equation, and then we solve it, and we just use the double angle formula to simplify this complex trigonometric ratios. And the final value for the range, the horizontal range, was v naught square upon g into sine twice of theta. Now we are moving towards our last equation, and that is the equation of the height, maximum height, the formula to determine the maximum height. Let's move towards it. Okay, the final equation is there, the equation to find out the maximum height. In the maximum height, we should again consider the same picture, but with some fluctuations there. Now here what you have to do, you have to consider this point first. And you can see there at this point, the initial velocity we are just considering as v naught y, because when it will reach here, it will be the final velocity and it will be 0 again. So we are just going to consider this point, and at that point the initial velocity is considered as v naught y. So in the maximum height we are going to consider the initial velocity, and that is equal to the y component, and that is v naught y. At this point we have to note down this, that at this point the initial velocity is equal to v naught y. We are just supposing it. And then the maximum height, you can see from this point to this point, this is the vertical distance that the body has covered. So we can say that s is equals to this height, and that height is equal to y, because it is in y-axis. So for that height, you are going to write down either h or you are going to write down either y. They both are equal to find out this maximum height. Or even we can say that this y is equal to h maximum. So we are considering this distance that is in vertical direction is equal to height maximum, or in simple words, that is the y. As you can see there, the body is moving from here to that point, and it is against the gravity, the force of the gravity. So the value of g will be minus. Here at that point it will be plus because the body is coming down, but here it is moving against the gravity. So the acceleration will be considered as minus g. So we are just writing it down. The acceleration will be equal to minus g. And the time that to reach the maximum height will be used. It means the single time will be used, and that is equal to v naught sine theta divided by g. So we have three equations of the motion: the first equation of motion, the second equation of motion, and the third equation of motion. Here And the height maximum, the equation to determine the height maximum, we are going to use the second equation of motion about the distance, that is S is equals to VRT plus 1 upon 2 at square. We are going to replace the values that we have written down in our understanding initially. We are just going to replace the values. Instead of this S, we can write down either Y, or we can write down height maximum, and that is equal to initial velocity. And as I told you, the initial velocity at this point will be V naught Y, and the time is there, and you are going to write down the time here, then plus 1 upon 2, then you are going to use the brackets there, and the A is minus G because the acceleration was against the gravity, and certainly T square will be same. Now here again you are going to replace the values again. This V naught Y is the Y component. Oh, sorry, I forgot to write down here. V naught Y will be equal to V naught sine theta. So we are going to put the values again, the value for the V naught Y, the value for the time to reach the maximum height, and again the value for the T to reach the maximum height. So we are going to use the brackets. V naught Y will be equal to V naught sine theta, then multiplied with the time. The time was V naught sine theta divided by G. Okay, now this minus and plus, they both becomes minus, and that will be 1 upon 2. The G will remain same, and then again we are going to write down the formula for T. So the T will be V naught sine theta upon G, and the whole square is there. You can just separate it by giving the line. Okay, so now we are going to multiply these both, and it will be V naught into V naught, V naught square, sine into sine, sine square theta, and that is G. Then you have to write down minus, then you have to write down 1 upon 2. Now this square will be distributed among these, and this G will be cancelled with one of the G's because there is this square. So the remaining will be V naught square sine square theta and divided by 1G. Because it is the square and there will be 2 G's, so one of the G will be cancelled with this G, and 1 G will remain here in the denominator. Now here we have to solve it by taking the LCM, and when we will solve it by taking the LCM will be 2G, and at the up the remaining will be 2V naught square sine square G, and minus, here we will have V naught square and sine square, and finally we will get the formula 2 and minus 1. It will be V naught square sine square theta divided by 2G, and that is the formula for the height maximum. Here in the last step we just solve the friction, and from this step you can solve the LCM by yourself if you do not understand that how did we solve this fraction. So by solving this fraction you will get the final value for the maximum height, and that is equals to V naught square sine square theta divided by 2G. So these were the 4 equations about the projectile motion, and that was all about this picture that we did. So I hope you understood about the projectile motion. Let me just repeat the projectile motion, the definition of the projectile motion again. The motion that is under the influence of gravity, and in that motion the two horizontal and vertical distances are covered simultaneously. Now such type of the motion is known as the projectile motion. Projectile motion is always free of the air resistance and the rotation of the earth, and it is always done under the influence of one acceleration, and that is the acceleration due to the gravity. I forgot to mention one thing. The angle that we have used here, that is always met at the center, at the point of the origin. And the projectile body, the body which is moving under the influence of the projectile motion, follows one path, and that path is the curved path, and that curved path is known as the parabolic curve. And to understand the projectile motion in detail, we have to determine the four equations. The first equation was to find out the time to reach the maximum height, and then the time of the flight, and then the horizontal range, and then finally we had to determine the maximum height. And we did it, and we proved all the equations. I hope you will find this lecture helpful for you. And for the handouts or for any query or any question, you can put your question into my comment box in my YouTube channel, and I will try to answer your questions. For the next lectures, subscribe my YouTube channel, like my videos, and I will keep uploading the next lectures. Till the next lecture, Allah Hafiz. Bye bye.